So today we're going to talk about Chapter 1, Psychology as a Way of Thinking. We're going to talk about how we kind of look at psychology in the field and how we can kind of understand different things about the course moving forward. So as a chapter overview, kind of the two large sections we're going to talk about and cover today are first, research producers and research consumers, and kind of the difference between these two roles being producing research and consuming research. And we're also going to talk about how scientists, specifically psychologists, approach their work. So let's start off by talking about research producers and research consumers. We're going to talk about why the producer role is important and why the consumer role is important and the differences between the two, as well as the benefits of being a good consumer. So you yourself, how you can be a good consumer of research. So we'll start off by talking about why the producer role is important. So first and foremost, of course, it's important for your coursework in psychology and this class specifically. It may also become important if you pursue a graduate school career and if you sort of endeavor farther on and want to do research in grad school or even working in a research lab now. Learning the basics and understanding the process of how research is performed and produced is important for all of these things. The consumer role is also important. All of us are consumers of research in different ways. Of course, again, for psychology courses, understanding how to interpret, understand, and consume research in a beneficial way is important. It's important to understand what you're reading when looking at different printed or online news stories that are based on research. And we're going to talk more in depth about how different stories may present the research in slightly different ways and possibly not always represent what was found in an accurate way. And then, of course, for your future career, understanding evidence-based treatments and how using that evidence is really important in understanding what is actually being found. So what do you gain by being a critical consumer of information? As a critical consumer, you should be thinking carefully about the information you're seeing. You should be critical of what that information is truly telling you and not necessarily take what you see at face value. You should think deeper. So in your textbook, there's actually an example that talks about facilitated communication. And so this treatment is essentially an attempt to aid people, often with autism or other communication disorders, who are nonverbal, with being able to communicate. And so what's done here is that a moderator or a facilitator sort of helps guide the person's hands over some type of keyboard to be able to select different keys and communicate through this method. However, this has not been found to be an evidence-based treatment. So what that means is that although it appears that the person is communicating, in reality what's often been found is that these communications aren't really coming from the individual, but are actually coming from the moderator who's guiding their hands. So in reality, it doesn't provide a true means of communication for the individual that needs assistance. So let's talk a little bit about how scientists approach their work. So first and foremost, scientists are empiricists, and we'll talk about what that means. They test their theories and use the theory data cycle. They also tackle applied and basic problems, and also sort of a transitional method in between as well. Scientists dig deeper. They don't just necessarily stop with their first finding or the first answer that they come across. They dig deeper and look for further explanation and answers to their questions. They make their results public. We'll talk about the publication process and how scientists go from producing research to sharing it with the general population. And then, of course, how they talk to the world, from journal to journalism. So we'll talk about scientific journals and then more sort of consumer-based journals and the differences between them and how that process sort of evolves and changes. So first and foremost, we'll talk about how scientists are empiricists. So what is empiricism? Some of you may have heard of this before, but the empirical method or empirical research is essentially the idea that evidence is based on the senses, things that we can see, hear, touch, or instruments that can help these senses. So different things that can measure attributes that are able to be picked up by the senses. This is essentially the idea that we observe and we trust things that we can see or that we can touch. Scientists don't just believe something because it was said to them or because it seems like it makes sense. They have to be able to observe it themselves. Let's talk about the theory data cycle, and we'll use sort of this example here of what this theory data cycle involves. So the theory data cycle talks about how we start with a theory and we take that theory and we transition it into a hypothesis, test that hypothesis, and arrive at some form of data that derives a conclusion. And that conclusion can either feed back into the theory or possibly improve or change the theory. So one example here that we can use to show this process is a study that was performed by Harry Harlow back in 1958. There were basically two competing theories of why infants form bonds with their mothers, not necessarily just humans, but also animals as well. And so they wanted to test these two theories, one being the cupboard theory and the other being the contact comfort theory. The difference between these two theories are essentially that the cupboard theory is that children form bonds to their mothers because their mothers are a source of food, and that's the primary reason for the bond to be there. That's where they go to get their nutrition and form of life. However, the contact comfort theory said that this bond was more an attachment to the source of comfort and cozy touch, and that's what really helped enforce that connection. So what Harlow did is derived a study where there were these two sort of mother figures. One was sort of a bare wire cage that provided food. You can see that on the left of the screen here. The other one didn't provide food, but was warm, comfortable, and provided that sense of comforting touch. What was found is that the monkeys, when given the choice, often preferred the warm, cozy mother monkey over the bare, cold wire one that provided food. And so we can see from this that we had two competing theories. A hypothesis was derived for each, and we see that the data, or the outcome, that monkeys tended to prefer the warm, comfortable mother figure supported the contact comfort theory and did not support the cupboard theory. So again, just to reiterate and kind of run through the process, we start with a theory, and this theory leads research to pose particular research questions, which lead to an appropriate research design. And in the context of the design, researchers formulate what's called a hypothesis, or a set of beliefs about what they think will happen. Researchers then collect and analyze data, which provide feedback and feed into this whole cycle. Now, if the data supports the original theory, that once again sort of feeds back and supports the theory and only strengthens it. However, if the data does not support the theory, we see that it either revises the theory and can help change it, or maybe helps just sort of revise and change the research design. This can be done because maybe the research design didn't accurately assess the theory, but it wasn't the theory that was necessarily wrong. So good scientists test theories, but good scientific theories have to also have certain characteristics. Like we said before, a good theory is supported by the data. Once you arrive at data that you find supports the theory, that only helps to strengthen it. Theories also have to be falsifiable. So falsifiable means that a hypothesis that's tested has to be possible to fail. It has to be possible for the hypothesis to not be correct. So a falsifiable theory isn't necessarily false. It just has the ability to be proven false. An example of a falsifiable theory is the theory that lions were louder than tigers. This can be tested, measured, and shown to be false. On the other hand, an example of a non-falsifiable theory is the existence of God. Here, there is no method for this theory to be tested or empirically observed. Good scientific theories also have to have parsimony, or be parsimonious. All other things being equal, the simplest solution is the best. If a simple theory predicts the data as well as more complicated theories, then you go with the more parsimonious, or simple theory. And finally, theories don't prove anything. That's often a common misconception, especially with consumers of research. But theories do not actually prove anything. When referring to theories, instead, psychological scientists opt for phrases such as the data supports or are consistent with the theory, or the data do not support or are not consistent with a theory. Scientists evaluate theories based on the weight of the evidence for and against the theory. So now let's talk a little bit about different types of problems that scientists observe and attempt to solve. So we can see sort of this transition from what's called basic research to applied research. Basic research really here is the goal to enhance the general body of knowledge about a particular topic. So for example, conducting a study to investigate what 9-month-old infants can remember about hidden objects. Basic research can often be a foundation for later applied studies. From there we kind of go to what's referred to as translational research, which is a bridge from basic to applied research, in which findings from the basic research are then used to develop applications. And then finally we have what's referred to as applied research. Here, this research is conducted in order to solve some kind of practical real-world problem. The word applied means that the findings will be directly applied to finding a solution to a real-world problem. So an example here is conducting a study to determine the best method for teaching young children how to read. There's practical real-world applications to that study. So here we see an example of basic research understanding what parts of the brain are active when meditators are meditating. And then we see how that can kind of transform into translational research, in where a laboratory study can study if meditation lessons improve college students' GRE scores. There we sort of see that development of some form of application of the research. And finally, we have the real-world applied research, where we can see basically if using meditation in an actual school program has helped students focus longer on their math lessons. So this study was actually performed by Mrazek and his team, but they didn't stop just after finding whether mindfulness and meditation affected GRE performance. They dug deeper, and this is an example of how scientists don't necessarily just stop at the first finding they have. They didn't stop at that translational research level. They continued on and said, how can we use what we found in the real world? How can we apply this in an applied research setting? So they took that and tried to understand if mindfulness training, something similar to meditation, was especially helpful for people whose minds wandered the most, and if this was something that could be used, once again, in a real world setting. Let's talk about sort of the publication process, or how scientists go from creating research to sharing that research with others. So first and foremost, the first step that scientists do is often to simply submit their work to a scientific journal. And so what are journals? They're essentially periodicals that typically are published every month, sometimes maybe quarterly, so 4 times a year. And the articles in these journals are peer-reviewed and are written by qualified contributors. So what does peer-reviewed mean? Essentially, that's the idea that a scientist submits their work to a journal, and other scientists read and review that work. Sometimes they might go back and forth a couple times with the work until everyone in the review process believes that the work is suitable to be published and shared with the rest of the community. We're going to talk a little bit about the benefits and risks of journalism coverage. Is the story important? Is the story accurate? And also understanding the difference between what a scientific journal is and what simply journalism is. Journalism specifically is the popular media or popular press. It's what most of us read in magazines, newspapers, or simply online, what we hear on the radio or what we see on TV. And these sources are often written by journalists, not necessarily scientists. And their audience is the general public, so it's written in a way to be understood by many people. They don't necessarily require specialized or specific knowledge on the field, and journalists usually find out about a research finding by reading about it first in a scholarly research journal or attending some form of professional conference, and then they turn that information into a more accessible news story to reach a wider audience. So let's talk about an example of how sort of the scientific news cycle might work. So you start off with your research, which finds that your conclusion is that A is correlated with B, given C, assuming D and under E conditions. It's translated by your university PR office, which then takes that to some sort of newswire organization that shares that A causes B, says scientists, who are read by people on the internet and taken by cable news stations. Finally, as that continues, you see that your grandmother reads and now believes sort of this inflated state of what your research was actually saying. So you can see how this cycle goes from findings that aren't always true, but may be supported by data under certain circumstances, to something that is represented and understood as the ground truth. As the information is translated from journal to journalism, we often see these findings being misrepresented by over or underinflating the results. This leads the average consumer to misunderstand the intended results of the study. Let's take a look at an example of this in this clip.
And for all those reasons, scientists themselves know not to attach too much significance to individual studies until they're placed in the much larger context of all the work taking place in that field. But too often, a small study with nuanced, tentative findings gets blown out of all proportion when it's presented to us, the lay public. Sometimes that happens when a scientific body puts out a press release summarising the study for a wider audience. For instance, earlier this year, a medical society hosted a conference at which a paper was presented comparing the effects of high and low flavanol chocolate during pregnancy. If that sounds narrow and technical, it was supposed to be. There wasn't even a control group of women who didn't eat chocolate. And the study found no difference in preeclampsia or high blood pressure between women who ate the two chocolates. So there is no way a study that boring can make it to television, right? Well, wait. Because that medical society issued a press release with the much sexier but pretty misleading title, The Benefits of Chocolate During Pregnancy. And because most TV producers just read press releases, this happens.
Turns out if you're pregnant, eating 30 grams a day of chocolate, that's about 2/3 of a chocolate bar, not the whole chocolate bar, could improve blood flow to the placenta and benefit the growth and development of your baby, especially in women at risk for preeclampsia or high blood pressure in pregnancy.
Except that's not what the study said. It's like a game of telephone. The substance gets distorted at every step. And I can only imagine how someone who watched that segment must have described it the next day. Oh, the news said our baby is made of chocolate and it's okay if I eat it, but only 2/3. And it is not like the media needs help blowing things out of proportion. Remember that Time story about farts and cancer? It turns out the study never mentioned either of those things. It just pointed out that certain sulfide compounds are useful pharmacological tools to study mitochondrial dysfunction. And while that Time story was later heavily corrected, the scientists told us that we still get phone calls and emails from strange radio and TV shows wanting us to talk about farts, which is clearly a waste of their time. They're doing valuable work. They shouldn't be wasting their time fielding calls from drive time DJs Gasman and The Beef. And there is no doubt some of this is on us, the viewing audience. We like fun, poppy science that we can share like gossip, and TV news producers know it.
Another example of this is called the Mozart effect. This phrase was coined after a study found that playing classical music to children appeared to improve their performance on test scores. However, this effect was only found under certain, very specific circumstances. It wasn't a very strong effect, and also appeared to happen with all genres of music. However, like we discussed previously, when this finding was reported through journalism, the results were taken very strongly. There were actually a series of books that were written convincing parents to play classical music to their young children. Even specific music was made and sold to try and convince parents it would improve their child's intelligence. This wave of misinformation was kind of like the game of telephone, where each person changes the story just a little bit, to where finally what's being published in books is nothing like what the original study actually found. So if there's one thing I want you to take away from the lecture today, it's this idea, that what you read about scientific studies shouldn't always be taken at face value. As we go through this class, we'll continue to learn how to think critically about information and learn how we can each evaluate the merit of what we're observing. All right, so to wrap up, I'll just review the topics that we talked about here in Chapter 1. We talked about the differences between producers and consumers of research and the importances of each of these. We talked about how scientists approach their work, right? The theory-data cycle, where we go from theory to hypothesis to data that either supports or helps modify and change the theory. We talked about the difference between basic to translational and then applied research. the peer review process, and how scientists dig deeper and continue to ask questions. And then, of course, the process from journal to journalism, how scientists are peer-reviewed in order to publish in scientific journals, and how often that translation from journal to journalism and being consumed by average consumers can sometimes lose some of the initial meaning of the research. So all of this kind of ties into the idea that you, as a consumer of research, should be aware of how these things relate to one another. How if you read something on the news or hear it on the radio, that you should now maybe be thinking and be aware a little bit that maybe what you're hearing isn't exactly what was found. And so that's what I want you to think about kind of going forward throughout the rest of the semester, is I want you to kind of think critically about the different research we're talking about. Not even just in popular sources, but even journals themselves, even research that has been peer-reviewed and published. I want you to think critically about the research and think of questions. Is what I'm reading, is what I'm understanding actually what was found? And under what conditions was it found?